Hi, my name is Andy Ritger. And I'm going to be talking about a new Linux OpenGL API. Testing. Yep, that works. Oops. Yeah. Yep. Okay. All right. So starting with history. So the current Linux OpenGL ABI that dates back to 2000 states that libgl.so.1 must export all OpenGL 1.2, GLX 1.3, and R multi-texture entry points. And so first, this is a little bit antiquated. It focuses on GLX, and obviously EGL is becoming much more prevalent. So it would be nice for OpenGL entry points to be provided separately from GLX and EGL, so separate those out into separate shared libraries. And it would also be nice to guarantee more modern OpenGL entry points. The second really major thing is that technically the OpenGL ABI today requires that libgl needs to be in user lib. And so, of course, the big problem that we all run into today is library collisions. Mesa's libgl, NVIDIA's libgl, AMD's libgl. So we need to find a better way to coexist together. So we don't have a good standard mechanism for multiple OpenGL implementations to coexist on the file system. And as a result, distros have to invent linker tricks or alternatives mechanisms, but all that gets to be fairly distro-specific. So the goals for this, so we wanted to find a new ABI between applications and the OpenGL libraries, separating out the Windows system libraries, EGL and GLX, from the client API libraries, OpenGL and OpenGLES. Client API is a term that comes up a lot in the EGL spec, so that's the terminology I'll use here. We want to allow multiple vendor implementations to coexist on the file system. We'd like to allow multiple vendor implementations to coexist within the same process, make current on one thread to something rendering on an NVIDIA GPU, make current on another thread to something rendering on an Intel GPU, for example. And we want to allow vendors to provide extensions and new OpenGL versions on their own schedule. NVIDIA is typically pretty aggressive about releasing a driver that has the new version of OpenGL support same day as that OpenGL spec is released. Our Windows teams are going to continue to do that. I want to make sure that we can continue to do that at NVIDIA for Linux as well. And it's paramount that we reserve backwards compatibility so that existing applications continue to work as they do today. So I'll go into details about each of these libraries in the next few slides, but to summarize, there'll be a set of, with this proposal, there'll be a set of vendor-neutral client API libraries. So lib OpenGL, lib GLES for versions 1, 2, and 3. There'll be vendor-neutral Windows system libraries, so lib GLX and lib EGL, and important that that's lib capital GLX, not to be confused with the server-side lib GLX. We're going to hate that. And then there will be vendor-specific backend libraries that get for libglx and libegl. And I should clarify, just in case it's not clear, by vendor here I'm referring to the OpenGL implementation, so Mesa versus AMD versus NVIDIA versus any other provider of OpenGL. Okay, so for the vendor-neutral client API libraries, so libopengl.so.1. As a straw man, I would propose that provides symbols for all OpenGL 4.4 core and compatibility profiles. Vendors can provide additional entry points through getproc_address, but no EGL or GLX entry points would be exported by libopengl. And then basically the same thing for the GLES libraries. No extensions advertised as symbols. Everything would be accessed through getproc_address. And this is just a straw man, so we can negotiate whatever entry points make sense. Okay, then the vendor neutral Windows system libraries. So libegl would provide the symbols, and again, as a straw man, EGL 1.4 entry points. And libegl will be responsible for loading and dispatching to one or more vendor libegl vendor libraries. And then same thing with libglx, it would provide symbols as a strawman for the glx 1.4 entry points, and then load and dispatch to the appropriate vendor library. So then the vendor EGL and GLX libraries, these would provide an initialization function that the vendor neutral EGL and GLX libraries would call. So vendor neutral library loads the vendor specific library and then calls the initialization function. That would pull in the vendor's implementation of the client APIs that vendor implementation supports with that Windows system. Let's see here. Then at make current time, the vendor library would register its client API implementation with the vendor neutral client API library. And the vendor libraries should not provide anything that collides with the namespace of OpenGL and GLX and EGL. Yeah, Daniel?
Is there a reason for them to export any symbols, really? Other than what you need for init, obviously.
I think the only thing they really need is init. Yes. No symbols, period. Yeah, that's fair. Yeah. Okay. Good point. Good point. Yes, yeah. Okay. So dispatching to the vendor implementations. The vendor neutral libraries obviously need to dispatch to particular vendors. So the question is how to do that. For the client APIs, that's relatively easy. Make current defines, you're talking about a context. That context will map to a vendor. You're making current, so this thread of execution should get dispatched to that particular vendor. So for anything that's context specific, that's relatively straightforward. It's slightly harder for the Windows System API. GLX and EGL entry points, some of them, or many of them, imply a vendor through their arguments. So as an example, GLX entry points that specify a screen as an argument, either explicitly or implicitly by some object they name, a drawable or a context, or those are good examples that you created with respect to a screen. So there's that category of Windows System entry points. Some Windows System entry points dispatch based on the current context. For example, EGL waitGL doesn't take any arguments and operates on the current thread of execution, just like a client API entry point. And then some Windows System entry points return current API state, like GLX get current context. And for that class, we could probably just have adequate bookkeeping in the vendor neutral Windows System library to satisfy that and not have to worry about dispatching. But in nearly all cases, and there's a few oddballs to be dealt with, but overall, in almost all cases, the vendor for a Windows System entry point can be inferred one way or another. And I should note that as part of this effort, we're not trying to address server-side vendor neutral GLX. So the point's a little bit academic. If given a particular X server, only one vendor's server-side GLX implementation is going to be loaded at a time. Though, if you're a masochist, you could be talking to multiple X servers at the same time. So, and we shouldn't rule out the possibility of doing solving server-side at some point, but the motivation for that is probably not too high. You could, I think for GLX, you'd most of the time only be talking to one vendor at a time. Yeah. Yes, but the server-side GLX implementation, there'll be only one vendor loaded at a time. Yeah. Okay. So Here's one example flow. So in this case, the application is linked against libopengl and libglx. The application starts by calling some glx entry point. Based on the arguments passed to that entry point, libglx figures out what screen we're talking about, requests from the X server a mapping of screen to vendor. Based on that, the vendor neutral libglx loads and dispatches the libglx, loads and dispatches to the vendor specific libglx library. And then that vendor implementation services all of the glx API calls. Then at glx make current time, the vendor specific library calls back to the vendor neutral libopengl, registers all of its entry points, and then that sets up the dispatch table. Then the application starts calling opengl entry points, and those jump through the dispatch table that the vendor implementation registered, and then from there the vendor's on its way. Yeah. How the vendor implements that is up to them. I mean, I would expect. So, short answer, yes. From an implementation standpoint, I would expect vendors to split out the OpenGL implementation into some separate library that could be shared between libglx and libegl. But I think that's an implementation detail that I don't think this should mandate. Ian, you have a furrowed brow.
I mean, it seems like one option here is to have the vendor-specific library export both GLX and EGL and all of the OpenGL stuff as well. So you'd have one giant vendor-specific blob that exported both the Windows System APIs that we need, as well as the OpenGL API. Alternatively, you're going to just have this. Right, and then that library wouldn't expose. Then that wouldn't have the GLX entry point. So when GLX went to look for it, it wouldn't find it in that module.
I mean, I think we also kind of want to. I mean, it'd be sort of nice to design for additional Windows systems in the future. It's sort of nice.
Right, and that additional Windows system would just get slotted into the same giant blob, right?
Yeah,
I can imagine.
Sure. So, I guess one question is, should that be a requirement of the API, or is it an implementation decision that, okay, we have this all in one shared library, and then like we set up symlinks so that the libglx vendor and libegl vendor point to the same massive blob.
Yeah, symlinks are a pain, but yeah,
yeah,
as an alternative.
Yeah. Okay.
So my question then was, where does all the protocol stuff live for indirect rendering?
Within the vendor implementation.
Libglx _ vendor or libopengl? Because that seems weird.
the libglx vendor.
Okay.
I mean, I guess from my point of view, I'd like for the vendor neutral libraries to be as low maintenance as possible.
Right.
And so for that, make them as thin as possible, and then defer anything complicated to the vendor implementation. Yeah. Adam needs the mic.
The problem I have with that idea is, like, right now, I know that Mesa's client-side indirect code is, well, direct and indirect is just doing broken things. So if the protocol dispatch code lives in GLX vendor, then yours and mine are going to disagree, right? And if I try to run Mesa's libgl against a indirect against a server that happens to have NVIDIA's GLX loaded, we at least need to agree at some level on the details of the protocol, which we can do, or we can just put the majority of the things that we've decided, here's how the protocol works, in libcapglx on the client side, and the only thing you need to dispatch into libglx vendor for is glx vendor extensions.
Yeah.
And it, in a real sense, most of that code is not high maintenance, so it's just that it's been abused on our side. So I don't really see a huge maintenance burden in putting most of that in libcapglx on the client.
Yeah, I disagree a little bit. I mean, there's some problems where you have an extension that redefines how existing entry points work. So when we add a BBO, for example, draw elements changes how it dispatches. So it works for 99% of the cases, but it might break some future extension, and it breaks a couple of existing ones. Yeah.
Okay. It's fine for me. It's for the best. Okay, so so another example using libegl, pretty similar to the last diagram. Really, the only difference is how does libegl figure out which vendor to use? Handwave, magic, and I guess it's been a while since I've looked at the Mesa implementation of this. We probably don't need to spend presentation time, since I suspect we're going to be short on time, but I think we'll have to work out how exactly that selection works, but I'm sure we can do that. Otherwise, this is the same flow as in the GLX case. Okay, so now for backwards compatibility. So we need to provide a libgl such that existing applications that look for it find it, and it behaves basically the same. So I guess the proposal would be that there would be a vendor-neutral libgl.so.1 that would be part of the vendor-neutral library package. This would export the union of all symbols that all vendors of libgl provide today, and we can poll to figure out what's that.
There's only like 4 vendors.
Yeah.
I mean, it's Mesa, AMD, NVIDIA, Matrox, maybe. That's about it.
Yeah, I don't know on the more mobile or embedded side.
I don't know of any. There you're talking about GLES for the most part, so I don't think that
good point.
libgl is that relevant. The question was, do the ARM Chromebooks have a libgl, and the answer appears to be no.
Yeah. So anyway, I don't think it'll be hard to go build that list.
I think IMG does have GL support on some of their devices, and maybe Vivanti.
Okay.
I mean,
yeah.
Yeah, I've never actually seen it in person, but I've heard.
It's a small list.
Yeah. In the interest of time, I think outside of this meeting, we can go hunt down that list and put together a straw man proposal for here are all the entry points that libgl should provide, such that an application that runs with any of the existing libgls will find all those symbols in this new model. But the question is, how should each of those symbols be implemented? For the symbols that the vendor-neutral libgl will provide, that are also provided by the vendor-neutral libglx and libopengl, we can use ELF filtering to point those symbols at the vendor-neutral implementations in libglx and libopengl. For symbols that wouldn't be provided, say if there's vendor-specific symbols in the libgl that aren't provided by libglx and libopengl, then I think we'd need to fall back to get proc address. But that should be doable.
Get proc address there would be returning a code-generated slot in a big dispatch table?
Just wait. Yes.
Okay.
Yeah. There's a whole challenges section.
Sorry, I was skipping ahead.
No, that's fine. But that is a very good point. Anyway, one way or another, all the symbols that libgl provides would have to get routed to the right thing inside the new model. But the goal would be to make that transparent to applications, and I think we could get there. And then for distribution, hopefully once we get these libraries up and running and tested, we'll get to a point where they require very little maintenance. From a vendor's point of view, distributing sort of asynchronously to distro releases, I'd like to be able to drop in a new libglx and libegl vendor, replacement, on whatever release schedule I need, and I imagine other vendors would have similar sorts of requirements. So the straw man proposal here would be, once we get these vendor neutral libraries into maintenance mode, we contribute them to Kronos for hosting. They'd be packaged by distributors and distributed as part of the Linux distribution. And then distros would manage distribution and packaging of that, and distribution and packaging of the vendor libraries, or the vendor libraries would be distributed in a manner similar to how they are today. Implementation details. It should be separate from Mesa, I'd say, since it's but yeah.
Yeah, I think when we were talking about this earlier, I just said we should do X.Org, libgl.
Yeah. Yeah, I don't particularly care where it's hosted. Yeah. Yeah. Okay. Good. All right. So in terms of how NVIDIA views the migration plan for this, there's still lots of implementation work to do. But once we get to the point where we have these vendor neutral libraries and we're relatively happy with them, we'll migrate the NVIDIA OpenGL implementation to hook into these rather than provide a libgl, a fat libgl that contains our implementation. So we'll flip a switch such that we rely on the presence of the vendor neutral libraries. And then I think the big takeaway from this slide is that if we're installing through our sort of out of band installer, and the distro that we're installing on does not have the vendor neutral libraries, we'll just have the latest snapshot at the time that we built the driver, and drop in our copy of the vendor neutral libraries. So, and hopefully we wouldn't need those for very long, except installing on older distros. And that's the kind of model I would expect AMD as an example to use as well. Okay. So now for challenges. Get proc address with this. So get proc address is context and therefore vendor independent, and which means that the vendor neutral libraries can't dispatch directly to a vendor when they get a get proc address call. The proposed solution, kind of like what Ian's mentioned a few times today, you pass in whatever string to get proc address, GL ham sandwich, and the vendor neutral library generates a stub dispatch code segment, returns a pointer to that, and then at make current time, the vendor neutral library has to do all the resolution, mapping those stubs to actual indices in a dispatch table that the vendor provides, and that should work pretty well for client API entry points that are per context. It's trickier when you're using get proc address to get the address of a function for a Windows system entry point, because, like mentioned earlier, the Windows system entry points need to be dispatched based on the arguments to them. And so the best we can come up with so far is any vendor providing a Windows system entry point would need enough support from the vendor neutral library to actually redispatch the Windows system entry point itself. So I provide whatever GLX entry point, and it takes a screen argument, and then at the beginning, before actually doing my implementation, I have to look, am I the guy for this screen? If not, call something in the vendor neutral library and do some magic to have that call the vendor for that screen. And it's not great, but I don't have better ideas. Does what I described make sense? I think a lot, except we need to know what the function signature is. So I guess that, you can imagine utility code in the vendor neutral library that said dispatched based on a screen argument, and the vendor-specific library would get the call, take the screen argument, and then call the helper library, and it would go from there. So mull on that for a bit.
It's the last day. It's the last day.
Just a few hours left.
I know, right? So there's going to be relatively few vendor libraries, and there's probably not going to be that many additional functions that they'll each advertise. So I wonder if there's some way that when libglx bootstraps itself, that it could communicate with the installed vendor libraries and figure out what they support and assign functions. If everyone says, I support this, and then it could, you know, I don't know, do some work up front instead of when the application actually requests a thing, and then be able to dispatch it instead of having to ping pong back and forth between the two libraries and do a bunch of negotiation at the function calls. I mean, this is one of the hard problems. That's why I've always punted on this.
Yeah. Adam would like the mic. Sorry. Yeah, but to your point, Ian, about kind of how often are we going to run into this? Probably better to think about it in the context of EGL than GLX. I mean, we're probably not going to add a lot more GLX entry points, but we are going to add a lot more EGL entry points over time. So I think.
Yeah. So one possible model for this is looking at how I hate to say anything good about the DRI loaders, but they kind of have the pattern of here's a list of structs that where you get the name of the function and then you can elaborate a type signature after it.
Yeah. And
that can be something that you hand up to the libglx at initialization, or that libglx can DLSIM for in the vendor neutral libraries, and then it can know, okay, these are the names of the GLX entry points for everything. If I get asked for GLX ham sandwich, then I'm just going to generate a function stub that sets the error flag and bombs out. The irritating thing there is you don't necessarily want to go DL open every vendor library on the system to find this.
Yeah.
But you could probably, I mean, it's possible that we could make that some standard bit of metadata that sits on the file system somewhere. That's that true. We just open as a file early on and say, well, this is the list of functions and entry points that the installed libglx vendors have.
Yeah.
And that, because that's not going to change at runtime. Yeah. That's going to be something that either they know how to dispatch when they were built or they don't. And that's probably the simplest thing to do.
So that seems like that gets you the list of entry points, but someone still needs to have logic to know how to dispatch to them, and I don't know.
Well, so you get the list of entry points, and you can just write them as C, and then FFI does this. libffi is redispatch this function call with these arguments.
Okay.
Foreign function interface. It's built. Yeah. It's constructively build this API call and come back out. And we're kind of doing that by hand for the GL stuff right now, but once you have the type signature in this text file, here's the header, the C declarations, you have enough information to hand that to construct that function call out of libffi.
Okay, yeah, that's interesting.
Are you talking about the case where you say you want to say EGL make Windows Surface or create Windows Surface and then dispatch to different vendors based on what you pass in?
Based on the EGL display, yeah.
Okay.
Yeah, EGL device I don't think solves this. It's just another object that you can use to map back to a vendor. So I'll move on, but yeah, this is something that'll merit more thought. And I'll check out libffi. Okay, so another challenge, not quite as bad as get proc address. So to dispatch some GLX entry points to a vendor, libglx needs to use a GLX object, like a context or a drawable, to correlate that to a screen. From there, then to correlate to a vendor. My initial stab at this just did client-side tracking. Like, so when the context is created, record what screen that context was created relative to. Later on, when I see that context, I know what screen and thus which vendor I'm talking about. That's, I think, mostly okay for GLX context, since at an API level, what the application gets back is a void star, so that pointer really only makes sense inside that process. That's a little bit more dodgy with drawables, since they're XIDs, and so some other process could create that drawable, and then this process could name it, and so just client-side bookkeeping isn't adequate. We hacked up some GLX or some X extension to have the client-side library request the server do that translation for us, it will require a little bit of server-side work for the server-side GLX implementations to do that bookkeeping, but yeah, it's not hard. Oh, it's client-side? How does it? Okay. I guess a server-side request would probably work the vast majority of times. It seems like a little bit racy that an XID could be destroyed and reallocated to name a different object on a different screen, but I think that sort of race exists elsewhere in X today. Okay.
Even it doesn't matter. Like if the XID is destroyed and reallocated in the amount of time that it takes libgl to run this query, it could just as easily have been just destroyed and reallocated between the adjacent X requests and the client.
Yeah.
Like it's all, that race is already there.
Yeah.
It doesn't matter.
Yeah.
Yeah.
Okay. So for implementation status, so there's a very, very rough implementation available at this link. libglx and libopengl is mostly implemented. We haven't done anything for EGL or GLES yet. There's a partial implementation of the compatibility libgl.so.1. That implementation uses Mesa's GL API code, so all the great stuff for online generating the stubs and managing the dispatch table indices. So thanks for that. What's that? It seems to work well from my point of view. No? Okay. I haven't. It's from reading it. I guess we've not done much testing with it yet, so we'll see. And for this, we'll likely also leverage some of Mesa's EGL implementations of the front end bookkeeping related stuff for the vendor neutral libEGL. There's still a lot of implementation details to be worked out. The make current time resolution of vendor has implementations of these functions, and we need to map them to what got reported through get proc address is a little sketchy and probably not the most efficient. So I'm sure there's some iterating to be done there.
Do you actually see applications doing make current that often? Because it seems like they would already be hurting.
Oh yeah, make current is certainly very heavyweight. I don't want to make it more heavyweight than necessary, though.
I'm just wondering. I don't think I know of any app or Firefox, I guess. Well, we were doing the ignore that Firefox.
Yeah.
Yeah. Okay.
Yeah. Oh.
We see a lot of apps doing make currents to like the exact same context over and over again. So as long as that's fast, it's more or less okay.
Yeah.
But if you're making current between contexts, yeah, it's already slow.
Yeah. Okay. So as a next step, we're gonna try to wire up this vendor neutral front end to NVIDIA's OpenGL implementation, and my guess is that'll shake out a lot of problems, and start exercising the implementation we have so far. And based on the experiences of that, we can write a brief porting guide that may be helpful for other vendors on, what were the things we needed to do to get from current implementation where we provide libgl to this model. But yeah, that's where we are so far. Let's see here. I've got just 2 more slides. Sorry. So one FAQ that's come up a few times when I've talked about this with different people. I think we touched on it a little bit. Keith asked earlier, not directly this, but so why isn't there a lib opengl vendor? And I guess in this model, the only vendor-specific libraries that the vendor-neutral libraries look for at any point are the Windows system libraries, and then it's the vendor-specific Windows system libraries that register with back the other direction with the vendor-neutral lib opengl. How that's actually implemented and managed would be implementation specific, but from the ABI's point of view, there wouldn't be a need for specifically for a vendor-neutral, vendor-specific lib opengl. And then last, I'd like to give a big thanks to Brian Nguyen at NVIDIA, who's done most of the implementation work. I'm just presenting slides. And then for references, these slides are on GitHub, along with the initial proposal, and I've been updating that a few times with some minor things. The current implementation so far is linked here. And we started a thread on Mesa Dev. I hope that's an appropriate discussion place for this. I don't want to hijack the alias, but want to give visibility and solicit feedback. So it's kind of a lot of code to read through, but feedback very welcome. Yeah. Questions? No? Brian?
Not really any questions, but I just want to say that I like this a lot. I think it's high time we revved the Linux ABI, and I'm glad somebody's taking an initiative to do it.
Yeah.
I know it's been long overdue, so
Yeah.
I really hope that this all gets done.
Yeah, me too.
Thanks.
Good. Thanks, Brian. Okay, anything else? All right, well, I think, Ian, you said we should take a few-minute break? Yeah, let's take 5 minutes, and then I'll talk briefly. Yeah. All right, thanks, everyone.